In this video, we will look at examples of DFAs with loops on it. Okay, so for example, in this case, you have a self loop on Q0, and from Q0 you are going to Q1, and from Q1 you are going back to Q0, and it happens to be on the same symbol B. There is another example. There are two examples with loops and cycles that we will see and derive some conclusions. Okay, what we will going to do is we will take up a string w1, and then we will take up the state sequence for this string. Okay, so initially we will take one string that is acceptable. Let's see the state sequence. Okay, let's look at the state sequence. So initially you are at Q0, and when you see A, when initially you are at Q0, on B you go to Q1, Q1, Q0, 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 Q1, 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 Q1. So you end up at Q1. So it's a this W1 is accepted. This string W1 is accepted. Okay. Now just look at this. In this state sequence S, there is a repetition of the states. In the state sequence S, there is repetition of the state. In this case Q1, on seeing A, so if you are at Q1, okay, if you are at Q1, if you see A, then you will go to Q1. There is a self loop on Q1. So when you are at Q1, if you see A, you go to Q1. Okay, so there is one repetition here. There is another repetition. When you are Q0, on seeing A, you go to Q0. So when you are at Q0, on seeing A, you go to Q0. So the repetitions that are there is because of the self loops. In this W1 examples, the repetitions that are there is because of the self loop. Okay, now as you can see, so there is a repetition. If I take, let's say, if I take this W, if I take this one as W1, and let's say if I take it as W2, it means that Q1 on seeing W1 stays at Q1, and Q0 on seeing W2 stays at Q0. Okay, so you have moved from Q1 to Q1 on seeing W1. You have moved from Q0 to Q0 on seeing W2. What if there is another W1? Once you are at Q1, you see another W1. You again will be at Q1. So any number of W1 can be, you will still be from Q1 to Q1. Similarly, any number of W2 can be there. If you are at Q0 and you see W2, any number of W2, you will still be at Q0. This is what self loops are. This is what self loops do. Okay. So if you are at, let's say, if this is something, okay, then this state, if you are at Q and you see A, you remain at A, it means that if you are at Q and you see any number of A, you remain at A. You remain at Q. So this gives you, so and this is what? This is the final state. This is the final state. It means this A here, when you have repetition of from Q1 to Q1, this A here can be repeated any number of times. You will still reach to the final state, right? This A can be repeated any number of times. You will still reach at final state. Okay. This gives you a little insight about what the type of language it is. It is an infinite language for sure. It is infinite language for sure. In the DFAs for infinite languages, you will see repetition in the state sequence. So, in DFAs of infinite languages, you will see repetition in states, repetition of states. In a state sequence, and this repetition of states actually ensures that your DFA is going to accept infinite number of strings. Okay, and this also gives you a little idea about what type of infinite language you can give DFA. Okay, if the infinite language has a pattern which can be achieved through loops in the DFAs, then for that infinite language only DFAs are possible. Okay, let me take one example with let me take another W for considering this backward also, considering this this loop. Okay, let's take another string and the corresponding state sequence for that string. So let that string be B, 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 A. Let that string be B, 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 A. Now when you are at, initially you will be at Q0. Q0 on seeing B you go to Q1. Q1 on seeing A you go to Q0. And Q0 on seeing B you go to Q1. And Q1 on seeing B, on seeing A you stay at Q1. Q1 is the final state. Q1 is the final state. So W2 belongs to the Q1 is final state. So W2 belongs to the language of the machine. As you can see here, there is a loop. As you can see here, there is repetition of state. This is Q1. This is Q1. Okay. It means that we will take this BB as W. It means that when you are at Q1 and if you see B and B, you will again come back to Q1. Similarly, if you consider this state and this state, there is repetition because of BB. So when you are at Q0 and you see BB, then you will come back at Q0. Okay. So this is Q0, this is Q0. Within that, there can be many intermediate transitions that may happen for this W. But ultimately, you will be at Q0. So when you see a string, if you are at Q1 and the following string is BB, you will end up at Q1. There may be some intermediate transitions that may happen, but you will end up at Q1. That's for sure. So this is what looping is done. Looping is about. So what it means is this, that if you are at Q1 and you see any BB, you get back to Q1. Let replace BB by W. So if you are at Q1 and you see a W and you get back to Q1, then it means that if you are at Q1, you see any number of W, you will again be back to Q1 regardless of how many intermediate transitions occurring there, but you will get back to Q1. Okay, for W2, ultimately you are reaching at Q1, that is the final state. This Q0 and Q0, you can have any number of B's. Any number of B's, you can have B to the power K, and and in the you can have any number of b's bb to the power k, and if the following string is ba, you will get to the final state, and that will be accepted. Okay, this is how the this is how loops work in DFS. So that is what it is. In case of DFS of infinite languages, you will see repetition of states in the state sequence, which is because of loops, in the DFS, and this repetition of a state is what is responsible for a finite number of states to generate infinite strings. Now, and if you think about it, this repetition of a state is actually what is necessary for any DFAs to be able to generate the infinite strings of any infinite language. If you can't understand it, look at the example of DFA with no loops at all. Okay, let me construct a DFA with no loop at all. So if you look at the state sequence for this one, W1 is A and B, A, B. So you are at Q0. When you see A, you go to Q1, then you go to, from Q1 you go to Q2, and from Q2 you go to Q3, and then Q3 will repeat, So for W1, Q3 repeats on B, it will repeat on A also. You get anything, let's say the string continues to be on A, then it stays at Q3, it sees B, it stays at Q3, because it's a dead state. Q3 is a dead state, whatever comes it stays at that place. So before you reach dead state, before you reach Q3, before you reach Q3, this is the sequence of states. Before you reach dead state. Okay, and it has no repetition in states, no repetition of states in the state sequence. No repetition of states in the state sequence. And rightfully so, because we have seen if there was a repetition, we have seen that. If there was a repetition from one state to another, if there was a repetition from one state to another on seeing any symbol or on seeing any string, it means that any number of that string comes, you will have the same state, and that will give rise to the infinite language. So language cannot be infinite. So this is what our conclusion was in the last video also, that in the DFAs for finite languages, if you have self loop on any move, it must be a dead state, and except apart from dead state, you cannot have any cycle and you cannot have self loop. Okay. Now the question is, given a DFA, can you identify what the language is? Given a DFA, can you identify what the language is? Like for example, this is the DFA. Okay. For example, let's take this DFA. So it is clear that it's an infinite. Okay, make Q1 as the final state. So it's clear that there is a loop, so the language must be infinite. Okay, so there is a final state Q1 which is reachable, so it is clear that there is some language to this DFA, and that language is also infinite language. So what is that language? The guideline is very simple. Number one, how do you construct DFAs? You are at the initial state, you look to go to the final state. What is the language of this DFA? This is your M1. What is the language of this? So you are at initial state. So to give what the language of the DFA is, just look at how you can reach to the final state. So from initial state Q0, on seeing any symbol, you go to Q1. Let's say Q1 is the final state. If you see any symbol, you go to Q1. And then you stay at Q1. Q1 is the final state. So to reach to the final state, you have to see any symbol. It means what is the language? Language is A, B, and all the strings. So it is every string except epsilon. If you can see any string, you reach to the final state. So the language is any string except epsilon. Okay. Take another example of a DFA. Let's take another DFA, M2. Let's say this is your Q0. On seeing A, you go to Q1. And Q1 is the final state. And on seeing B, you go to Q2. And make the Q2 as dead state. And Q1 as the final state. So how can you reach to the final state? So from initial state, how can you reach to the final state? When you see A, you go to the final state. Once you are at the final state, whatever comes does not matter. So when you see A, you go to the final state, and then whatever comes, you are still in the final state. All these strings are going to be accepted. It means that, and if you see from initial state, if you see B, you are going to the dead state. So this is what it is. This is what the language of M2 is. This is what language of M2 is. So what is L of M2? Strings that start with A. Strings that start with A. Strings that starts with A. Okay. We'll take one more example and we will end this session. Make Q2 as final state. Okay. So on seeing A, you go to a, let's say you go to dead state. Okay, this is the string. So this is the DFA. So what is the language of this DFA? What is the language of the DFA? From initial state Q0, you can get to the final state by BA. From initial state you get to the final state by seeing BA. Okay, and after that anything can come, any string can come, I don't care. We will accept all strings. So from initial state, if you see BA, you go to the final state. So that's what the language of this DFA is. So the language of M is all strings that starts with BA. All strings that starts with BA. So this was one example where I was just showing you that because this is a infinite, there's loops, and so infinite language, and this was just a demonstration of how infinite languages are going to be accepted. But if you have to guess what the language is, you just look at the initial state and you see how you are going to reach to the final state. Okay, how you are going to reach to the final state from initial state or from any other state. Let's say if there is a let's say that you have you can here it can be any number of any architecture, and you go to the final state QF. So to go to the final state, so that's how you approach. From initial state you go to the final state. Now from final state it may happen that you go to any other state. Okay, so it might also happen that you are at final state and you go to any other state, and there is a way to come back to the final state with any architecture possible within that state QI to QF. So that's what it is. If you have to understand what the language is, look at how you can reach the final states. Look at how you can reach to the final states. That's it. Thank you very much.